Hey, what's up everybody? Not too long ago we did a video on the TIDRADIO TD-H3. Great little radio, for the price especially. The harmonics had a little bit to be desired, and TIDRADIO has now sent me over some new radios. So let's take a look at them and see how they do on the harmonics test. And we're also going to open one up and take a look at what's on the inside. So let's head over to the bench and see what we've got. All right, let's take a look at these three radios here on the spectrum analyzer. I have my 40 dB attenuator and a little piece of RG316 to hook to each radio. I started using this because I had a previous attenuator that ended up developing an open, and I believe it's from putting on and off all these HTs. So this is my, I say new, I've been doing it for the last several videos and it works out pretty well. It doesn't seem to, I haven't had any issues with this attenuator since. So the oscilloscope that's on the screen right now is set up from 140 megahertz to 800 megahertz. We are at a bandwidth of 100 kilohertz and 10 dB per increment on the display, and we're just going to take a quick look at the entire spectrum here. So let's get this first radio hooked up. The spectrum analyzer has also been set to account for the attenuation of this attenuator, plus all the cabling that is in between the radio and the scope. So let's make sure these are off. This one is on. All right, we are on 146.5 megahertz on low power. Okay, so what we see here is the fundamental frequency there as our first spike, and we do see our second and third harmonics popping up on the screen. They are considerably below that negative 16.02 dBm line, which is equivalent to 25 microwatts. And to just do a quick recap for those that are new to the videos, FCC Part 97 requires that transceivers below 25 watts, the harmonics need to be at least 40 dB down from the primary frequency. And on top of that, those harmonics individually all need to be below negative 16.02 dBm or 25 microwatts. So what we'll do now is we're going to switch back over to the harmonics display that I normally use. And we will go here to harmonics. We will put in our frequency of 146.5 megahertz. We're going to limit our harmonics down to the first 5. And let's go ahead and turn on averaging. We'll take the average. That's right now averaging every 10 samples. So that's good. Let's leave that there. So now let's take a look and see what we have here. Okay, so this radio is showing that our fundamental frequency is 30.23 dBm, and our second harmonic is minus 52 dBm down, and our third harmonic is minus 66 dB down, and our fourth and fifth are way down, way down. So this looks great on 2 meters. We are seeing that it passes all the requirements. All of the second, third, fourth, fifth harmonics are greater than negative 40 dB down from the primary, and they are all below that negative 16.02 dBm line. So that is excellent. Let's try the next radio. What I'll do is go through each radio on 2 meters, and then we'll go back and look at each radio briefly on 70 centimeters. Just because these radios did have that strange second harmonic on UHF. Okay. All right, so here we are. We're on low power, 146.5. And let's see what this one looks like. Okay, so this radio, the fundamental, we're at 29.17 dB. That second harmonic, wow, that's really pushing it. Look at it, it's a little bit above that negative 16.02 dBm line. it's great because it's minus 44 dB down from the fundamental, and the third one is negative 65 dB down from the fundamental. But that second one, it's just bothering me. Looks like it's just a little bit above that negative 16.02 dBm line, which, I don't know. This radio I might give a fail to on low power. Let's try high power and see what it looks like. On high power, okay, on high power we get a pass. We are negative 62 dB from the fundamental on the second harmonic, negative 58 to 60 dB on the third harmonic, and then way down there on the fourth and fifth. So on high power, this radio easily passes all criteria and is below the negative 16.02 dBm line. Let's go back one more time and look on low power. Wow, that's right on the line. I mean, literally right on the line. I'd say maybe within the margin of error of my test equipment, maybe, you know, I would squeak this by on a pass because that is right at the requirement. So there's radio number 2 on 2 meters. We'll squeak it in with a pass. That's really, really close on that second harmonic being right on the line. All right, and let's take a look at radio number 3 on 2 meters. Make sure, do I have those off? Those are off. Okay, here we are, 146.5, low power. Wow, look at that. It's almost the same as the last radio, right on that line. So I guess I'm going to give this one a squeak by pass also, because within the margin of error, that is literally right on the line. So here we can see the second harmonic is 46 dB down from the primary. The third harmonic is 62 dB down from the primary fundamental frequency. All that passes easily on the FCC criteria, and they are below the negative 16.02 dBm line. That second one is right on it again. Let's take a look at high power. On high power, okay, on high power we're getting a pass here. Second harmonic is 62 dB down from the fundamental frequency. The third harmonic is 60 dB down, minus 59, about 60 dB down from the fundamental, and everything is below that minus 16.02 dBm line. So we get a pass there on high power. So actually this radio is hooked up. Let's just, what we're going to do is switch to 440, and our test frequency for 440, I have 446.0 in here. So let's change our spectrum analyzer to 446 megahertz. And we will use the secondary push to talk and see what we've got here. Okay, 446 on low power. Look at there. The bad second harmonic on UHF is completely gone on these series of radios. I will try to post a little graphic up on the screen to show you what it looked like on the previous radios before TIDRADIO sent me over these current radios. So on low power, here we see second harmonic 64 dB down from the fundamental, third harmonic 68 dB down from the fundamental. Now this is another situation here where the FCC Part 97 doesn't technically cover the 70 centimeter band. That regulation actually says up to 225 megahertz. Personally, I still like testing my radios just to make sure they're clean. And I know you're going to say, why? You know, I get all the questions in all the videos. Why does this matter? Well, as a ham radio operator, one of the things that you're supposed to be cognizant of is whether or not your equipment is operating properly and not causing any spurious emissions or interference to outside of your band or the frequency that you're operating on. So just as a ham radio operator that likes to make sure his equipment is clean, that's the main reason that I check these. The spurious emissions and these harmonics, they can interfere with other things that are in close proximity to the radio if they're transmitting on frequencies that they're not supposed to. So that's why I like to make sure these radios are clean. And it is an FCC regulation, so these manufacturers should be being held to that if they want these radios to be sold in the United States. So let's take a look at this radio on UHF. And here, once again, this radio is good to go on UHF. They have definitely removed that harmonic issue on the 70 centimeter side of the radio, so that is great to see. So here we see second and third harmonics are 61 and 61 dB down from the fundamental, and that's on low power. Let's take a look at high. High power, we're good too. Negative 63, negative 64 dB from the fundamental. So, and that's dBc, so dB change from the fundamental frequency. So that looks great on low power and high power on UHF. One more radio to test on UHF. Alright, we're going to switch to UHF. Use our secondary push to talk. Didn't turn this one off. We are now. So here we are on low power. Look at that. Those second and third harmonics way down. 65 and 72 dB down respectively for the second and third harmonics. So yes, I would say that they fixed the harmonic issue on UHF. Even though that is not specifically part of Part 97 requirements, but it cleans the radio up, and that is excellent. Let's just double check high power. And high power, we are still good to go. 64 and 65 dB down from the fundamental. So the one other issue that I had on these radios from video number 1 was that the output power on UHF was all over the place on these. One radio was 0.2 watts, one radio was 0.5 watts, I think. They weren't consistent. So let's take a look and just see what we've got here on the UHF side of these radios. All right, on 446, we'll check low power first. All right, so that's interesting. On low power, this is saying 1.38 watts forward on low power. So let's see what we have. Oops. On high power. 5.3 watts forward on high power. So all right, so that's a good place to start. 1.3 watts on low and a little bit over 5 watts, 5.21 watts on high. So let's check this radio next. All right. Low power, 1.26 watts. I'd say that's acceptable. That's really close to the other one. And let's try high power. Oops, wrong push to talk button. 5.4 watts on UHF. So that's very close to the first radio. So this is a good indication, if we continue in this direction, that they have addressed their consistency issue with the output power. I know they emailed me and wanted to know what my thoughts were on where the radios should be consistency-wise, and it looks like that they did a good job. I don't want to get ahead of myself, We have one more radio to test here. All right, we're already on low power. And we have, well, that one's 1.5 watts, almost 1.6 watts on low power. And on high power, 6. So this radio is a little bit hotter than the other ones. So this one's almost 6 watts. But at least we don't have that situation where 2 of the 3 radios before were putting out 0.2 watts and right around that range, even lower on low power previously. So I think that's a plus. And actually, let's just, in order to cover all of our bases here, let's switch over and look at 2 meters. Low power, 1.87 watts forward. And 6 watts forward on 2 meters. And I'm pretty sure that we'll see the same thing on the other 2, but why not just go ahead and look since we're here. This video is already going to be a long one anyway because we're going to tear one of these apart next. All right, switch to 2 meters. Low power. 1.24 watts. Low power. And 5.5 watts on high power. I would say if there was one thing that I could still wish for in these radios, you know, these things are so feature rich for the price. It's crazy. I'm not even gonna, as I already stated, or even will probably state again in this video, I'm not going to go through and go feature by feature on these radios. There's a tremendous amount of features, and it's been very well documented in other videos on YouTube. Simple things like being able to clone a transmitting radio, you know, just one frequency. You can grab the frequency and the the CTCSS tone, and then store it right into a memory. I think that's a neat feature. There's RF radio cloning. On the latest firmware on these now, you can actually input a frequency down to, I want to say 17 or 18 megahertz, which allows you to tune in, you know, the 27 megahertz band on FM. So that's also another feature in this latest firmware. But I'm getting sidetracked. So let's switch to 2 meters. All right, this one, 2 meters low power, 1.67 watts, and on high power, 5.6 watts forward. So all of these, I think, pass the consistency problem that we had before with power output. I'm very happy with what I just saw there on the power output on all 3 of these. And you know what? I didn't finish my previous thought. If there's one thing that I could maybe ask for on this radio, would be I would love 3 power settings. I would love a low, medium, and high, like they have on the TD-H3. I know that they do that there because that radio goes up to 10 watts. But I would still love to see a low, medium, and high, even on these. Even if high is still only 5 or 6 watts as it is, I would love to have a low that might be only like a half a watt, and then a medium that is maybe where these are now, 1 to 2 watts, and then the high being 5 to 6 watts. And the only reason that I say that is if you're using your HT and you're just accessing a hotspot in your shack or whatever, you don't need to be transmitting hardly any power at all. So it would really extend battery life and reduce the RF required, you know, to transmit from one desk over to your other desk or whatever the case may be. So I think that pretty much summarizes that. Let's go ahead and move on to the next part and tear one of these things apart. All right, let's see what's inside this TD-H3. So we'll take the antenna and battery off. These screws here, I'm using a T9 Okay. Pull off the volume knob. Now we need to remove the nuts on there. We're going to use our UV5 trick where we use the knob from the top. We're going to use that to take off the antenna nut. Always works really well for that. Put that aside until later when we need to put the radio back together. And then the one on the volume knob we'll just try to loosen with our screwdriver here. Alright. Set those aside. Now hopefully this will just, see here, how do we separate this? I think I'm going to use another tool here. I'm going to get a little pick that I have and just try to see if I can grab inside the screw hole and just sort of pull up. Yeah, it's coming. All right. There we have it. Now this will just separate from the front. Okay, actually I like this design. The front speaker is just connected through these two spring connections here. We have two springs here at the bottom of the board that come in contact with the speaker here in the front of the case. I like that a lot. Makes it easy for taking the front case off. And then the keypad just sits in there. That's pretty much ready to go back together when we're done. Alright, so it looks like this is going to be one of those situations where the antenna is not going to be able to be pulled out of here. We're probably going to have to desolder the antenna connection. So it looks like we have 4 screws here on the bottom of the board, which means that the others are hidden behind the LCD screen. So let's take a look and see if we can get this LCD screen off. I'm going to have to put on these nasty things so I can see. And it looks like, actually check that out. There's a screw underneath the LCD that is actually holding the carrier that holds the LCD, so we can't just lift that off. So it looks like we're going to have to pull the LCD out of this carrier. And I'm guessing by the fact that it doesn't want to just lift up that they've probably got maybe some double-sided sticky tape underneath there. I'm going to try to carefully use this knife and see if I can lift up on the LCD. Yeah, there. Oh, yes. All right. There is some adhesive under here. Let's see if I can get under that. All right. Here we go. All right. You can see here, see that white adhesive? They've got that on the stuck to that plate. So there's our LCD. We'll just flip that over, and that exposes now our our one additional screw here that will allow us to take that plate off. Let me switch to my Phillips. And there we go. All right, we'll take that off. And then we'll proceed here to take off the remainder of these Phillips screws that hold the board to the main frame slash also probably heat sink for the radio. All right. Let's see if we can disconnect the LCD. So there's a piece of black fabric tape here. Let's see what's under that. All right, so that's holding the LCD. We'll keep that on the side here so we can put it back on. All right, so we will lift our retention arm there and then pull the LCD connection out. All right, so now we can set our LCD aside. And okay, so they got some Kapton tape underneath there. And I don't know, I'm trying to see here. Hopefully we can see. So we've got the microphone here. Might have to get underneath the microscope here and let's just sort of see. Well, I tell you what, let's get the rest of the board. Let's get the rest of the board separated from the frame here. So it looks like here's our solder connection for our antenna. Let's get the soldering iron warmed up. I'll tell you what, let's turn on our microscope here and let's see if we can get a solder point for the antenna. See if I can get that a little bit better in focus for you. All right, we've got our soldering iron warmed up. We'll clean our tip and get some desoldering braid here and see if we can remove this solder from the antenna connection. All right, now we will try to lift up as we heat this. And I think we're separated. So we'll put that back and then we will see if our board lifts off here. So it looks like we've got a thermal pad here that lines up with that guy right there. So that says KC251. So we'll look that up, but that is probably going to be the amplifier chip. So let's see. Well, while we're looking here on this board, let's back out a little bit and see what we can see here. So we've got lots of, looks like some filtering here. Let's see here. Got a 5807 chip down here. And then try to get this so we don't have a glare on it. All right, so it looks like our radio chip here in the TD-H3 is a BK4819, which is common radio on a chip. This one in particular is the one that was in the Quansheng radio that has been firmware hacked all over the place to do all kinds of neat things. Here's an unfortunate thing here. It looks like we are still on the same microprocessor that was in the TD-H8 and is also here, the TA3782F. And unfortunately, I think when we start to look this up, this is still going to be hard to cross-reference. I don't know if it's a custom chip, but if you try to look up that TA3782F, there's not a lot of reference. If you guys find anything or have any information on this, please post it in the comments below because there's not a lot of information on that chip. Let's see, over here we have an EP, what's that? An EP2T45. We'll have to look these up and see if we can figure out what all of these are. Here is a TDA2822G. TDA2822G. This is an LM2904B. this here is a CH340N. A CH340N. If I had to guess, with the USB port right here, this might be, looks like the data lines might come over here. This might be a USB conversion chip, maybe USB to TTL or to serial. So that gives us a pretty good view of this side of the board. Just sort of going through here. Hopefully you guys can see. There we go. EP2T45. There's the TDA2822G that we looked at earlier. We'll have to look up and see what those are. Here's our infamous, I think, microprocessor, that TA3782F that we don't have any information on. Let me see here. That's the LM2904B. There's our BK4819 radio chip. I think that right there, the KC251, I believe, is probably going to be an amplifier, RF, maybe. And lots of little inductors and capacitor circuits there, filters. 5807M. All right, let's just look on this side real quick. What do we have down here? This is a BL24C64A. I believe that's an E² prom, I believe. Let's see, what else do we have over here? A GT21L 16S2Y. I think that might be also a prom, an E² prom. I'm not sure. Here's our audio. This chip has showed up, I think, in the other radio as well. The Audio-K2208. I would obviously guess that's some sort of audio, either amplifier or processor of some sort. Of course, our microphone. What else do we have up here? $6119A, 6119A. Look that up too. All right. Well, there you have it. That's pretty much what's inside of a TD-H3. I'm going to try to clean up a little bit where that flux was for the antenna. All right, and then we'll go ahead and put this thing back together. So the first thing we'll do is we'll get this lined up. See if we can get our antenna to line up. And there we go. We are through and soldered back to the board. So now we will just proceed from here on putting everything back together. So the first thing we want to do is put our Phillips screws back in. We'll start with this one here. And then we'll put the 4 in the bottom. Then we'll put our plate back on. Oh, don't get ahead of ourselves. First, we better put our LCD back in. All right, so we would like to get our ribbon cable in here. Lock it back down. Take our little piece of black fabric tape, put over that to sort of hold it, extra hold. Now we'll put our plate back in. And make sure that all of the through hole pieces are where they should be. All right. Now we'll lay our LCD back over here. And we do still have that adhesive, so that's going to hold it back down. Now, let's see here. Do I have a microfiber cloth here real quick? I'll just make sure that we don't have any fingerprints on our LCD. All right, that's looking good. No dust. All right, we've got our little cover for our headphone microphone jack. Now we should be able to slide this in. Let's make sure our keypad is in the right spot. We should be able to just slide this in, just like that. And then just to be safe, we'll test it before we put all the rest of the screws in. Oops. Welcome. All right, looks good. So we'll finish our assembly. We'll take our T9 again. Honestly, this is one of the easier radios to tear down. Comes apart real nice and goes together really nice. Now all that's left is our little nuts here to go on the top. We'll use our UV5R tightening knob. All right, go there. And this one we'll use our tool here that we took out, and we will just spin this one down. And I will use the screwdriver to just sort of tighten that up. And that's it. We are good to go. We've got our radio all back together. Oh, where's our knob? Here it is. Welcome. All right. Let's head back over to the desk and we'll finish up. All right, so in summary, this little radio is still pretty darn good. The feature set for price point is absolutely amazing. At the time of making this video, the firmware version is currently, actually, let me pull that up real quick. We're going to go to turn the radio on first is helpful. Menu 42. As you can see here, we are on version 240427. So April 27th of 2024 is still the most recent firmware as of the making of this video. Make sure that you have your TD-H3 updated to the latest firmware. There's been a lot of fixes. This version of the firmware has addressed several things. A couple key points. Squelch tail issues have been fixed. Push to talk button now transmits immediately even when the screen is off. You can now, one of the big things is in VFO mode, you can now input frequencies down to 18 megahertz. This allows people that are interested in the 27 megahertz band to type in frequencies directly. So I also want to go through some of those chip identifications from the video. The BL24C64A is an E² prom. The GT21L is listed as a font chip. I'm assuming that that must mean that it is a simplified Chinese font chip. The EP2T45F10E is a Bluetooth LE chip. Of course, the TA3782F microprocessor, if you guys can find any information on that, every time I query it, I still get the same results from back when I did the TD-H3 radio. Not a lot of information out there. There's some link to a Russian, I think, blog post or forum talking about that same chip in a Radtel radio, I think is what it was referring. The BK4819 is, of course, the two-way radio IC. The TDA2822G is an audio amplifier chip. The LM2904B is a op-amp chip. The 6119A, which was underneath the Captain tape on the front, is a 3.3 volt regulator. The 5807M chip is a broadcast FM receiver, so for the FM reception of broadcast radio stations. And the CH340N is in fact a USB to UART chip. So if there's any chips in there that are still in question, or if you guys identify any other chips, or if any of my identifications are wrong, please comment in the below the video and keep us updated. Once again, I really like this radio. Feature for price, it really still cannot be beat. I'm not going to go through every feature of this radio. I think this radio has been very well covered on YouTube. My thoughts are the harmonics now seem to be in check, which is great, because now this radio is a phenomenal little radio for the price. The feature set is unbelievable, and I think you probably can't go wrong with this radio for an introductory radio or just an extra radio to have around the shack. So with that, I'm going to say 7-3s, everybody. Thank you for watching. If you would please subscribe and like the video, that helps out tremendously. I would greatly appreciate it, and we'll see you in the next one. Thanks.